Good morning, everybody. Good to have you with us today. We may wait for another minute, maybe, before everybody join the conference. Okay, so maybe we can start now. We have attendees that still arrives. So thanks everyone to be with us today for this JEC Connect webinar or presentation. The goal of today is to inform you about our structural core material, the SAERfoam Series. That is a perfect fit to replace PVC, PET or balsa approach in industrial applications. So what you can expect from this presentation is first to see the product in use. I think it's very important for you to see that, even if it's digital. We have prepared a video for that. I want also to share this innovative draping solution that Zartex has developed for this product, and also share with you the success story for a marine customer. I'm introducing myself. I'm Nico Werner, sales manager for industry EMEA at Zartex, and I'm working with Zartex for the last 13 years. And basically, I'm coming from the marine industry earlier on. All right, so across this presentation, I'm going to explain you this core material concept of the foam, also what could be the available products, what are the available solutions and options, the product in action, and the cat space capture mold success story, as I just mentioned before, and I will wrap up with the 5 benefits for the sandwich laminates. All right, so the core material concept of SAERfoam. This product is a so-called engineering core. An engineering core is the concept of using a lightweight material where we are introducing glass fiber through the thickness to handle the shear loads, compression loads of the sandwich structure. Let me show you that in a small animation there. So we can see this lightweight product. It can be PU, it can be polyurethane. So it is polyurethane. It can be PIR, polyurethane with a bit more cyanide in it. We can also use polyethylene, but the main product, the main use that we have currently is out of polyurethane, because that's the best match for industrial solution at the moment. So within this product, we're introducing glass fiber with a specific patented process, and we're introducing this glass fiber with a specific orientation with an angle of 45 degrees. We can also do 90 degrees, but most of this is 45 degrees to handle the shear loads. And this will connect basically your A face to the B face and connecting the two skins together. Oh. Sorry. Then the product can be used as any other type of core material by laying down glass or carbon or amide or any kind of hybrid material on top or on the bottom, and then we do use this product mainly in RTM or infusion processes. It is fully compatible with epoxy, with polyester, but also we have customer using it in phenolic resin or polyurethane resins. This is a multi-compatible glass sizing in it, so it works perfectly and perfect match for that. Definitely, it is a product for closed mold processes, because that's where we will get the most of the mechanical properties out of this product. Okay, so this is the concept of the product itself. So let's see how does the product looks like. So the product looks like this. This is on this example. This is a polyurethane base foam core on which we have introduced glass fiber within a specific process. This goes to connect your A face to your B face, and you have remaining available glass on top and on the bottom to connect with the skin. And again, this is a perfect adhesion with the upper and the lower skin. within your laminate. And this on the right hand side here is a laminate made out of SAERfoam, where you can see the A face and the B face skins that are connected with this glass. We call that glass bridges. And the interesting thing of that is that because of this connection, you have a perfect connection and a perfect security against the lamination between the two layers of your skins. It is also an interesting product because due to or thanks to all these glass bridges, we have a number of connections that enable a very good permeability of the product. So within infusion, for example, you have a very good infusion rate, infusion speed, and you will definitely avoid having dry spots while infusing large parts. So let's just define a little bit the range of the product very quickly, and just like the snapshot there, we have the SAERfoam 60, the SAERfoam 80, which are the two standard products. The SAERfoam 60 is a bit more dedicated to RTM process due to the foam core we're using in it. SAERfoam 80 is the perfect match for infusion process and large part because you can work on it. You can really use it in hulls or in large shells. And we have the last product, which is the SAERfoam Plus. And the SAERfoam Plus is more like the bespoke product because we are producing on order this SAERfoam Plus, and the engineering team of Zartex is able to define specifically the weight and the mechanical properties that match to your requirements or certifications. And this SAERfoam Plus also, I would say, integrate the fire protection solutions, which are Leo solutions for fire protections. The product is available from 10 to 30 mil, and the sheet dimensions are 120 by 120 in standard sheets. Okay, so now we go into the product itself, into options. These are the typical options we have, and that's where we are going to see some interesting things that differs from what we can see on the market. This is a common groove sections to help the resin to flow. We do provide kittings from a facility in Europe. And we are also able to have this concept, or this new concept, of drivable grid core solution. This grid core solution has been called puzzle pattern at Zartex. These enable to have a very good surface finish while having a draping surface. So here is a small example of that. We are basically cutting about 2/3 of the thickness of the core and having no cuts on the other side. What completely differs from what you may know on, for example, balsa or PVC or PET, is that usually you have a screen behind that holds all your squares. With this puzzle system, you have no screen, and this enables to have very nice shapes, curvatives. But maybe I can show you that into actions, and that will be easier for you to understand the system that we do use. Let me, yes, here we go. I'm going to comment live on the video. Okay, so first at our facility in France, we produce that product. We can also do CNC cuttings. So we start with the CNC cutting here, where we can cut 45 degrees or 90-degree angles. We can do very sharp edges, and then we do prepare that into boxes for kittings that our customer can have a ready-to-use material straightforward. We definitely have the systems with the keyboards to connect all things together. We see here the draping solution, where we can very easily drape the product. On one side you have the puzzle side, and on the other side you have the non-cutted side to get the perfect surface finish. We can combine the two products together, having puzzle and grooves. So the grooves will be there for the resin infusion, and the puzzle is there for the drapability. We can also make it tailor to the size of the requested customer. So you can see here from a puzzle that we can deform this product within a certain angle, certain radius here. But also, if you have like relatively smooth curvatives, thanks to the BU, you can also not use them. Just let me pause there. Yeah, because that's an important thing here. You can definitely avoid having the puzzle or the grid score because the polyurethane is a relatively deformable product, so you can save resin intake by having a plain sheet to follow your curvature. And then this product can be used like any other type of core laid on the fabric, assembly kit, very simple assembly kit there with keyholes. And one part of that kit has been made out of here on the right hand side is the puzzle, and the other part is made out of the plain sheets because we don't have much curvature there, and we need a much better durability on this side. That's why we can see it here, plain sheet on the left inside and innovative puzzle solution on the right inside, which would save resin consumption. Okay, and then you can infuse it. Straightforward. And the infusion speed, yeah, here's the timeline, but the infusion speed is very excellent thanks to these multiple bridges that you can see gets impregnated very, very quickly. And it means also that the B face, the face underneath, is quite well impregnated directly. So you avoid also having the difference between the two resin fronts. We also can see that here from this side, you can witness here the puzzle, which is on the A face, B face, the mold face. You can see here that we avoid having any cuts from the grid one. So again, on the A face, the puzzle, and on the B face, no puzzle because there is no cuts through the thickness. Okay. So now I want to share with you a bit of information about this success we had with Katana Group, CatSpace Catamaran Deck. So this has started in Tunisia back years ago, 3 years ago, when Katana Group, which is one of the largest manufacturer of catamaran in the world, was looking for making a new model. This was a model that they want to produce one every 2 days. This is a catamaran deck, which is about 100 square meter. And the idea was to do all the deck in RTM and the hull in infusion, and to be as quick as possible and as reliable as possible to produce that. And this has been quite a success because we've been through a lot of different applications with the customers and engineering. And we have defined a SAERfoam 60 for the deck. Yeah, maybe the picture is a bit small here, but you can see here this part that has been demolded, and we are using the SAERfoam for the deck, also together with Zarco Max, which is an RTM product there. And from the feedback of our customer, the main benefit for him was in RTM to avoid having any risk of failure when closing the mold, especially when you get balsa or when you get PVC. It's quite risky to close the mold if one of your kit template is not correctly adjusted into the mold. And definitely it is a safe way to use SAERfoam there. And also the other one is the better impregnation through the thickness compared to PVC and PET, because thanks to these multiple bridges across the thickness, and which are glass, it enables to have a very good impregnation there. The plan for next year or this year was a bit end of the pandemic, but we are starting the work to prepare early infusion. So this would be a very large catamaran infusion hull made out of SAERfoam 80. So that's what's the plan for. That's the plan for the end of the year. Okay, let me warm up with the 5 benefits against the existing solutions like PVC or PET. And now that you know a bit more about the product, and I'm sorry that I cannot answer all the not answer all the questions in the chat, but I will have some time to answer that, no problem, after I finish this presentation. So the first top benefit is of SAERfoam is, first of them is the shear modulus, the very high shear modulus, which is like about 3 times the shear modulus of PVC and PET. So this will definitely help you to reduce deflection, and also allows the new design to reduce thickness, because having these 3D glass connections really enabled you to hold the composite all together. So you have no longer like a skin, a foam skin. You really have like a composite that goes all across your thickness. Here we have a radar graph that shows you that the different solutions on the market can be either compared in lightweight, strength, stiffness, and cost saving. So definitely this product needs to be competitive in terms of cost saving, but then it also has to be a very nice compromise into lightweight. So here, for example, the impregnated weight of SAERfoam will be between the PVC and the PET. In terms of strength, we will be similar to PET and PVC, where definitely balsa is very high, but I mean, no one is really designing in strength at the moment in industry. And the stiffness here is quite interesting, because you can see that the stiffness is relatively close to the balsa stiffness. So it exceeds by about 3 times the stiffness of a panel made out of PVC and PET. Here we have some mechanical properties. I may not go that much in details, but this presentation will be available for you guys, so you can go through it, and you can definitely be able to compare the stiffness, the compression, the shear, the compressive values, and also the impregnated weight. Third one is that it's an optimal product for marine application. Definitely because we are using closed cell core, so there is absolutely no water absorption into the core. It's also qualified for areas below the waterline, because even in case of a failure of the outer skin, Zardex have performed extensive tests comparing PVC, PET, and SAERfoam that shows that thanks to this 3D connection, your impact area, or the delamination area when you have the impact, is very, very limited, and it's similar area than what we can witness into PVC or PET. So you have no more water absorption than what you can do, what you can get within PVC or PET closed cells core also. That's a very nice product for curve designs. First, because if you have a slight curvatives, you can use it. You can use it as a plain sheet. So you can pass very large curve design without drivable version. It is also very stable. It has a very good dimensional stability. It is also a good product for installation, because we're using PU. So it's a product that fits very well to curve designs. And if you have a bit more difficult curve designs, then you can use the puzzle solution, which is a perfect solution for the curve shapes. The resin consumption can be reduced by €1 per kg thanks to these, just because we are knife cutting and we have like very sort of large puzzle pieces. And that also reduced the print through on the B face, which is this face here. For the example, of course, we've put out the gel coat to show you the by transparency. All right, so I'm very happy that I've been able to go through that. The presentation has been a bit short. I'm going now to answer some of the questions that I can see there. So one of the question here is how weight is comparing with and without the glass PU foam. So basically the PU foam is about 40 to 60 kg per cubic, and the glass is about 300 and 200 grams of glass in it. So you have most of it is PU because that's the spacer. So I would say that 20%, 30% of it is glass, and the rest is PU. The recyclability of SAERfoam is not proven yet because we have not been able to recycle the polyurethane. But thanks to this solution of SAERfoam, it does enable us in the future possibility to use recyclable foam core and then being able to reinforce it and bringing mechanical properties in it. And that's the entire concept of this SAERfoam. That's where we are looking forward for the sustainability topic. There is another question on the glass bridges. It's how about, are the glass bridges influencing heavily the density of the foam? So as I said, the density of the foam is written there. So you have the dry density here, which is about 60 to 80. Okay, SAERfoam 60 to SAERfoam 80, and you have also the comparison with PVC 80 and PET 115. So you can see here that these are the infused density, so the impregnated density. So that gives you an idea of what is the end density of the product. That's also interesting to see what is making PET, because PET is also is also a very heavy product at the moment on the market. Okay. Which pressure temperature has been done the RTM process of the Katana project? It is the room temperature project, so there is no assistance it is polyester resin. And for RTM, Katana is not eating the mold is not heated at all. Another question is, have you tried as well thermoplastic foam in this concept? Still better than PU? Yes, it is. We have tried a lot of different SAERfoam based potential products. Apart from PU, as I said, polyethylene, like polyolefins foams. What we need within this product is to get a product which is you get an even distribution of the cells, and with cells that are very regular. So we cannot use a foam that has been extruded, for example. That would have been a limitation. So we need an expanded foam. So we need to get expanded thermoplastic foams, which we have not found to match perfectly to this application. So one of the question is also, what is the difference between SAERfoam 60 and 80? It is just density. So the SAERfoam 60 is a 60 kg per cubic dry product, and the SAERfoam 80 is 80 kg per cubic. So the resin uptake for 1 square meter and 20 millimeter has been already answered. It was written in the presentation there. What influence on mechanical properties and thicknesses? I mean, there is no influences for you guys, because what Zartex has been developed is we are proposing a range of product that gives you the same mechanical properties no matter the thickness. Because obviously, as you may have understood there, Stefan, the idea is that more the thickness will be, more bridge more connection we need to handle the shear loads. So therefore, if you are ordering a SAERfoam 80 in 10 millimeter or in 25 millimeter, we are adjusting the bridges for you to make sure that it fits to the same mechanical properties, which is typically the shear strength. It is not possible at the moment to change glass fiber to carbon fiber. The reason for that is that there is no available distributed carbon fiber shop, so it doesn't fit to the process. Yes, so concerning buckling, that's there is also some question about buckling. It is interesting there because this product has a similar or even better buckling resistant than balsa, thanks to the very good stability through the thickness. And if you need more information, you can send me a short email and we can forward you some information about that. That some of the tests that have been performed. The product is not suitable for pre-preg. The reason for that is that we need resin to fulfill the glass bridges, so therefore it is difficult to use pre-preg for that. So we do recommend to use SAERfoam in infusion and in RTM processes or in compression molding. Yes, Gediminas get a question on conductivity or semi-conductivity of that product. Yes, in theory, yes, we can, as long as we are able to bring the particle additive within on the glass, then we can make that product conductive or semi-conductive. But if you want to discuss that furthermore, I just invite you to send me an email there on this email address, and I would be very pleased to answer your questions. Okay, I think I have asked all the questions. If not, I'm very pleased. I would be very pleased to answer any other ones. Just send me a mail here on n.vernin@zaertex.com. I can show you. We have another 2 minutes. I can show you some application and reference where we use the product. So we use the product at the moment in marine industry, in hull and bulkheads, in deck superstructures, in interior floorings. We do use that also in transportation, in floorings. That's a very interesting product to replace, for example, plywood in both floorings or in roofs for hydrogen roofings. So bottle handle roofings. We have a program to develop a specific product for wind energy. This is not ready yet, but this will be part of a second or of a separate launching. This is not ready yet. We have a lot of application at the moment into train business, in floors again, in doors, in sidewalls also, and we start having also application in claddings and in we used to have application in roof also, in roof for buildings. So I think I've answered most of the question there. Thanks everyone to being with us today. If you have any other question, really please send me an email and we will contact you locally. We have people worldwide to answer your questions. So send me that and I would forward to your local responsible. I wish you a good rest of the day, good rest of the JEC Connect today, and I say you goodbye. Bye.